Hello, everyone, and welcome back to class. I'm really excited to talk to you in this week 2 of the course. So, in the first theme of this class, we want to be able to cover the fundamentals of science. How do scientists study the world around them? And in week 2, we are going to investigate that step even further by taking a look at what they call the scientific method, a set of guidelines or ideas that scientists follow, much like a roadmap that you use to go from one location to the next, that allows us to interpret the natural world around us and how we decide if there is a phenomena occurring in that world for us to study and document and inquire about what concepts truly are driving that phenomena. This idea, the scientific method, was originally developed by the Greeks. But as time goes on, as we start to learn more and more about science, we start to add and change the interpretation of the scientific method, but there is still a core set of ideas. Things like observation, where we go out into the world around us and observe and inquire. Then we write a hypothesis. A hypothesis is just an educated guess, and scientists write that educated guess much like a sentence of cause and effect. We have a problem right here, and then we want to try to solve that problem using guesswork. Then we progress further and learn more about things like experimental design, variables, dependent and independent variables that we change in relation to a control group to begin to collect data. The same data that we collected in the previous week. Qualitative and quantitative data. Do we go out and observe or read about previous works conducted by other scientists, or do we collect hard data like length, measurement, be able to take that data and graph it and then interpret that relationship by analyzing it to determine if our cause and effect question or guess, the hypothesis, is correct or incorrect. Now, in science, how I view the correct versus incorrect of a hypothesis is actually, I prefer it as more of support, or needs a little bit more support. I find that there is no true yes and no questioning in science. A little radical. Most of the times, general science students, when they go and learn about the scientific method, they think it's a absolute yes or no when it comes down to confirming your hypothesis, but science is much more flexible. Science is just another way for us as humans to communicate about the world around us. It's a way for us to measure that communication and inquire and develop more thought about it. Then, after the experimental side of the scientific method or step, we can then go into conclusion to, again, support or add more support to our data using new evidence. Sometimes we even just have to go out and reconduct the experiment. And then we share it. Now, as we work our way through this week's assignment and content, I also want to talk to you more about the intricacies of data. How do we interpret data? Is some data considered to be good, or is it bad? Well, there's no such thing as bad data. It's just suitable or unsuitable, and we need to be able to kind of clarify that noise. But another big theme in this week's lesson is that of building a model. A model is something that we can be able to take a concept, something that's probably, let's say the air floating around my head in my office. That's considered to be a concept. There's concepts that drive that air pattern, that flow, but we want to look at something physical. Take a concept, an idea, and make it into something physical. So right now, I'm going to show you on how to build a model. And we can do this in science through experimentation. So right here, I have 3 large beakers. And my model that I want to learn more about would be what kind of human impacts would the world's global oceans see? Now that sounds kind of a weird question, but what I want to do is just basically look at maybe regional variations of the oceans. And we'll get more into this when we get into oceanography later in the semester. But I just want to be able to see what kind of human impacts can be noticeable in different types of our global ocean. I actually, to signify the beakers, this will be our control group. It's just going to be plain, regular tap water from the sink right over there. This beaker will be filled with water and ice. This will represent the model, a physical model, of the concept of what would define a polar ocean. And then this beaker right here will represent a more tropical to subtropical ocean, as it is loaded with a bunch of salt. When we get learning more about oceanic densities and oceanography along, say, the Atlantic seaboard and then down into the Gulf of Mexico and across the Mediterranean, the oceans tend to be a little bit more saltier, whereas polar oceans tend to be more dense because it's loaded with ice. So what I'm going to do is also use food coloring. This is, again, a part of my experimental design. The food coloring will represent human impacts. And so really what I want to do is be able to measure human impacts as they are introduced into 2 different regions in the water column. About a third of the world's population lives near the coastline, and these coastlines with a high population tend to be more subtropical to subtropical to tropical, whereas not a lot of people are living in, say, the Arctic Circle. So let's actually go and create a briny solution and a polar solution. I'm stirring it all up. Salt dissolves very easily in lots of water. But that's actually also changed variables, such as not only just adding salt, but the concentration of salt, to be able to make it as close as possible to oceanic water in our tropic to subtropic regions. Look at how briny that is. Next, we're going to make some polar water. And to do that, because polar water is not as salty, we just add ice to it. And then cold water. So the concept, again, behind this as a physical model is going to represent our oceans. And conceptually, I want to know what impacts humans have onto the global oceans as a model. So I'm just going to take some food coloring. I'm going to use red, and I'm just going to introduce it to the plain water, and just to give us a idea, and we'll measure, and we can measure the food coloring as it goes from the top of the beaker down to the bottom, and that will give us a fast or slow response to understand what is going to be defined as slow, what's going to be defined as fast as part of our experimental design. So I'll just put a little food coloring in. You see on how the human impact goes through the water column very quickly. So next, we are going to change our variables as part of our experimental design by investigating cold and warm salty water to see what kind of impacts are going on. So we can just put some water in it. And you notice on how fast that water and food coloring mix together. Let's try it in the salt water. Noticing how it's taking a lot more time. So this tells me that the salty water and the human impacts may not look severe compared to the polar oceanic regions, but also consider that the world ice is found in the polar region. So if the human impacts are this quick, then what might be those repercussions when the model is being understood and analyzed as far as the data? All right, hopefully this gives you a really good idea of experimental design, and we will investigate this more throughout the week. So if you have any questions, feel free to reach out during my open office hours. You can send me an email, swing by my office, or open up a video chat using class.com or Zoom. All right, thank you, and have an excellent day on our planet Earth. And next week, we are going to do some citizen science by going outside and doing a little bit of field work.